This is BMAT 2021, Section 2, Question 23. So this question tells us we have a cable with a current passing through it of 2000 amps and it's heading in the direction of west to east. The dimensions of this cable is 20 meters long and it's 120 kilograms of mass. The cable is supported, so it lies horizontal. We're also told about the Earth's magnetic field, that it has a value of 5 times 10 to the minus 5 T, and the gravitational field strength is 10 newtons per kilogram. And we have to work out what is the magnitude of the total force exerted by the support on the cable. So when we have things where we have to work out the total force, what I like to do is draw a diagram showing all of the different forces on our particular object, so in this instance the cable, to see if we can work out the net force. So take a second and see if you can sketch out a little diagram using all this information about the forces. So here's our little cable here. I've just drawn it as a really long cuboid. If we add in our current information, we know that there's a current heading from west to east of 2000 amps, and we also know that the magnetic field, which is going to interfere with this, is 5 times 10 to the minus 5 in a north horizontal direction. So it's going to look something like this with our magnetic field going north. So imagine this is flat to the plane and our current passing through our wire. If we then add our mass and our support, we're going to have a force supporting the beam there and its weight is going to be acting downwards. So we need to work out the total force exerted by the support. What information do we need to know? Well, we need to know the force supplied by the weight and also the force generated by this current. So what's the equation to work out force in terms of our current? So if I write that on here, the force is equal to the current times the length of our cable times the magnetic field. So if we put in our numbers from our question, we can see we've got 2000 times 20 times 5 times 10 to the minus 5, or this long number here times 10 to the minus 5. So if we just cancel these zeros out, we get 2 newtons of force acted on by the current. And now we need to figure out which direction this is going to go. And to do this, we can use the right-hand rule. So this rule, you take out your right hand, you're going to point your index finger forward, stick your thumb out, and also stick your middle finger out at a right angle to your index finger. You then point your index finger in the direction of the magnetic field and your thumb in the direction of the current, and your middle finger is then pointing in the direction of the force. So if we do this, we can see that the force is going to be pulling up on the cable. So you have 2 newtons of force pointing up here. So here I've simplified our diagram. This is the force brought about by the current. Now we just need to work out what the weight is so we can work out the support force. How do we work out the force exerted by weight? Well, this is just the mass times the gravitational field strength. So that's 10 times 120 or 1,200 newtons. And now we can work out the net force and therefore the force on the support. That's just going to be 1,200 take away 2 from this force here, and we get a total force of 1,198 newtons. So our final answer overall is answer D.